I've wanted to do a film explaining the programming of locomotive decoders for some time now, but I realise actually the subject is quite large and needs to be split down into little more manageable segments. As always, the best starting place is the decoder manual. They do have explanations of what all the configurable variables, the CVs, do. And I started doing this for the addresses of the locomotives and realised I now need to slot in a film before just to explain the structure of these configurable variables. As I've described them, or people have described them before, as a set of index cards that you store information onto that relates to how the loco behaves. A quick diagram here shows the 8 bits within a CV. If you think of them as 8 separate switches, when they're turned on they can activate something, when they're turned off they deactivate it. But you can also use those 8 switches to provide a decimal value, so say the brightness of the lights, the volume of the sound, the speed of a motor. And by combining bits you can get any value between 0 and 255. So all off is 0, all on is 255, and then any combination of switches on and off give values, so bit 5 and 6 added together would give you 48. So that way you can generate a sort of scale of brightness or of volume of sound or speed to the motor. So if we look at that sort of effect with the CV that controls the brightness of the headlights on this particular loco, go into programming on main, CV55 from the manual controls the brightness of output A, and if I read it, it's set to maximum. If I clear it and put in a very low value, you see how the lights dim right down. In fact, because it's a high frequency, the camera's picking up the flicker that my eye can't see. So I clear that again and return it to normal, 255, send. And up the brightness comes. Another good example that's easy to show is acceleration delay. So the loco is set up at the moment and it will accelerate quite quickly when I turn the throttle. If I go in to acceleration delay from the manual is CV3 and read that. It's got a value of 6. If I can go in and turn it up this way. Say turn it up to 60 and write it. Now when I whap the throttle up, the locomotive will accelerate off very slowly. Eventually it will get up to speed. Thought we'd just have a quick look at a volume control CV. So again, using the programming on main, got the loco idling away there. So it's a Zemo decoder. The volume control from the manual is on 266. So go into programming on main, 266, and have a look. Value set at 64. Now on the Lenz system I can turn it up. Okay, escape. So that's the main volume on the loco turned up. If I quickly go back, reset it back to where it was, 266, enter, we'll clear it this time and just put it back to 64, and when I write it, it returned back to the factory setting. So that's where understanding a little bit how the CV is set up can be very useful. Sound volume is one of the big ones that people question about. Different manufacturers put the sound volumes in different places. So that was a nice example using one that I read the manual on. So there is another way that CVs can be used, and that's as 8 switches switching on different functions. We're going to have a look at one that most people are going to come across, which is CV29, which is a sort of main settings CV. Back in the distant past, none of this would have been published, so it's quite fun to have it, but it's not really necessary to know it. We go in, read CV29, value of 14. So it's got a decimal value there, but I'm going to have a look at the bits that are selected. Now the first bit changes the direction of the loco, so if I activate that, send it, escape, escape. Now I've reversed the loco, so my throttle says it's going forward, but reality is it's going backwards. So CV29 controls a number of other things, so if I have a look in there, 29, click. Again, if we press the F button, we can show the bits that are activated rather than the decimal value. I'm going to correct the direction, and you see the headlights have just popped on. So the second bit tells the locomotive decoder that it's running on 28 speed steps, and 28 and 128 are treated the same. Older locomotives actually only ran on 14 speed steps, so some systems only support 14 speed steps. So if I get rid of bit 2 and write that, we might find things are a bit weird with the throttle, so the lights only come on every second speed step. So I can correct that in two ways. I can actually change the throttle so that it is selected for 14 speed steps, or I can change CV29 back. So now my throttle only goes up to 14, but my locomotive lights and everything are correct. Very occasionally do we run across locomotives that have got settings of 14 or 27 speed steps. 27 is from people that have used Fleischmann systems in the past, so the lock boss and the twin center defaulted to 27 speed steps. So in CV29 you would correct that by using bit 2. So put my throttle back to speed steps 28, and I'll correct the loco setting in CV29. So turn bit 2 back on, write that. So I've returned it to 28 speed step running there. Bit 3 tells the locomotive decoder whether it's going to accept analog power or not. So it'll always accept DCC power, but if bit 3 is activated, you can run it on a 12 volt DC analog controller. Bit 4 turns railcom off, so if I turn that off I'll lose the ability to program on the main track, so I'll leave that bit 4 alive. And finally there is bit 6. Bit 5 says whether you're using the speed curve that you set using CV2, 5 and 6. Sorry. and bit 6 tells the decoder whether it's using 2-digit or 4-digit addressing, and bit 7 and 8 aren't used. So CV29 is one of the sort of major setup configurable variables that you'll come across, and it can be used for fixing a number of issues that you may encounter. But quite nicely it shows that not all CVs are set by decimal value. In the case of CV29 you have to treat it as if it's 8 separate switches, switching 8 separate functions. So it all seems a bit daunting to start with, but the more that you use programming, the more that you'll get fluent in what you're going to be changing. We suggest only sort of starting with the first few CVs. So changing addressing is something you'll get instructions with your control system. Start voltage, starting delay, breaking delay, maximum speed and mid speed are all ones that you can play with and just see the effects. So we played around with acceleration delay earlier, which address 3, CV3, sorry. I put that way up to a value of 60. I'm going to put that back down to the original setting. So now the loco will accelerate it quite quickly. So we look at something like maximum speed, which is CV5. It's right up there, 254. Oops, let's clear that and put in a maximum speed of 50. Right, escape, escape, escape. Oops, too far. Okay. So now when I go up to the maximum on the throttle, that's as fast as the loco will go. And I can resolve that by putting it back to the original value. So go back into programming, CV5, read it, 50, clear it, 254 and write, escape. And once more the loco's back up to the maximum speed. So the decoder will be set so the maximum speed is also very similar to what it would run at maximum speed on analog. If all else fails, you can also do a reset on the chip. To do that, we will put it on the programming track. I've been working on the main because it's a nice way of showing directly what changes are made. The programming track is your safety net. So go into the main menu, programming and programming track, program CV, from the manual, CV8, set to a value of 33, will reset the decoder. Oops, let's try this again. What you'll also find is that because you've reset the decoder, it will have put the logo back to the factory setting of 3. I'll just put that back to 44.